Hey guys, welcome to another episode of Mrs. Woo's Algebra Notes. Woo woo! And we're going to go ahead and, I guess first I want to make sure that you guys are all doing well and staying healthy. And I hope you are taking care of yourselves. And what we're going to do is talk today about something called mean absolute deviation. This measures variability. This is also first introduced to you back in 6th grade, and if you don't remember it from back then, that's okay. So we're going to review all of it today. So like I said, it measures variability. So what that means is it talks about consistency of data. So what does it mean for data to be consistent? It means that all the values are close together. And there is not much variation. So I'm going to give you an example of a set of data where we have consistent data. So I'm going to give you a list. We'll label it as A. We have 1, 1, 1, 2, 2. So here is this list of consistent, where I have numbers repeating, and that they are close together. They're only one away from each other. Okay. Mean absolute deviation of a set of data is the average distance between each data value and the mean. Okay, it measures how spread apart the data is from the mean. Okay, so it measures the spread. If you have a small mean absolute deviation, your numbers are going to be consistent, they're going to be close together. If you have a large mean absolute deviation, then it means that your data values are very spread apart very far from each other. So again, just kind of in simpler terms, this MAD, this mean absolute deviation, it helps determine how much data varies within a data set. Okay. Now what we're going to do is I am giving you two small data sets, and we're going to compare them. We're going to compare the mean, and we're going to compare dot plots, and then mean absolute deviations. So when we compare their means, and I'm just going to do it the old school way, for your homework assignment, Google Forms, go use Desmos, make it easy on yourselves. But for the sake of notes, we're going to just go old school. Remember, for mean, we add up all the elements and we divide by how many elements there are. There are 4. When I add up my numerator, I get 12. 12 divided by 4, I get 3. Now I'm going to do data set B. Same thing, find the mean, we add all the elements together. We divide by how many elements there are, which is 4. When I add my numerator, I get 12. 12 divided by 4 is 3. Notice how my means are exactly the same, but I have different data sets. Now let's create a dot plot for each to kind of compare what the data set looks like for each one. So a dot plot starts with a number line. For this one, I have 2 values at 2, 2 values at 4. And I'm going to mark that I have my mean right here at 3. And I'm noticing how about each of my data values are 1 away from the mean. That's what I notice. Now I'm going to go ahead and do the same thing for my data set B. Again, start with a number line for your dot plot. Go ahead, mark 2 points for 1, a data point for 6, and a data point for 4. Again, I'm going to mark my mean in here. Here it is. And I see that my data values are more spread out than data set A. Okay, so that again, we have the exact same mean, but we have a different spread of our data. Okay, so one is definitely more variable than the other, this one over here with B, while A is more consistent. Now, if we apply this to the real world, creating dot plots for hundreds or thousands of data values, or whenever marketing does research, it's not feasible. It's not practical to do that, and it's time consuming to study your data plots. So instead, we use other measures of variability, like mean absolute deviation. To calculate mean absolute deviation, what we're going to do is we're going to find the difference of each data value from the mean, and then find the mean of that when we add them all together. Okay, so that sounds like a lot. Let me just kind of work it out. You can see what I mean. So again, what we're going to do is we're going to find the difference of each data value from the mean. So 2 minus 3, 2 minus 3, 4 minus 3, and then 4 minus 3. We're going to find the absolute value of each of these. 2 minus 3 is -1, absolute value is 1. Again, 2 minus 3, -1, absolute value is 1, 1, 1. Then I'm going to take all of this and add them up. When I add this up, 1 plus 1 plus 1 plus 1 is 4. And I'm going to find its average. So to find its average, again, we add them up and we divide by how many elements there are. There are 4. 4 divided by 4 is 1. So the mean absolute deviation is 1. What that means is each of our data values are about 1 away from the mean. And we actually see this on the dot plot. Let's try this again for data set B. Again, what we're going to do is we're going to find the difference of each data value. Okay, 1 minus 3. We're going to find how far it is away from the mean. And I just kind of read it from my dot plot. We're going to find the absolute value for each one, and then we will find its mean. So we'll end up adding them all together and dividing by how many elements there are. So the absolute value of 1 minus 3 is 2. 1 minus 3 is 2. 4 minus 3 is 1. 6 minus 3 is 3. Again, we're going to add this up. It gives us 8. We divide by how many elements there are, so we're finding its average, okay, the average of the distance away from the mean, and we get 2. So what this is telling us is that each of our data points on this data set B is about 2 away from the mean. Okay, it's a greater mean absolute deviation, so it is more spread out, which we can see, and it has greater variability. So the conclusion, we're going to just write down what I just said. Okay, so the conclusion again is that they have the exact same mean, but data set B has the values more spread out. So we know that because it has a greater mean absolute deviation. On average, and this is for every data set with its mean absolute deviation, so on average, the data set B are 2 away from the mean, okay? Which means that when we compare it to data set A, data set B has greater variability. Okay. So the second half of these notes are on a different video. I've been having major technical issues, so that's why the video is a little bit longer and a little bit choppier. Thank you for understanding and bearing with me.